Hello, hello. All right, guys. So today is day 11. It's Tuesday, February 2nd. I hope everybody's doing well. Here's our warm up. So let's go through it real quick and check it out. So, number one, how many valence electrons are in hydrogen? Well, to know that, we need to look at our homepage on Canvas and we go to our periodic table and star reference. We go down to the bottom to look at our periodic table. Look at that. Okay. And we're looking for hydrogen. So hydrogen's right here. Let's see if I can do something else. Make it a little clearer. There we go. So hydrogen is right here. And then in this warm up, it's also going to ask about calcium, which is right here, group 2. Okay, so hydrogen is in group 1. So how many valence electrons are in hydrogen? Well, since it's in group 1, it means it has 1 valence electron. All right, so valence electron, VE. So the answer for this one is 1. Number 2, if hydrogen forms an ionic compound with another atom, it will usually form a +1 ion. When hydrogen forms a +1 ion, it blank 1 electron. Okay. So this one is, let's see if I can change the color. Red on red ain't going to turn out good. There we go. So this is 1, was the answer to that one. So 1 valence electron for hydrogen. So if we draw a Lewis dot diagram for hydrogen, it's going to be H with a single dot there. Ain't that nice? So that's our Lewis dot diagram. So if hydrogen is going to form an ionic bond, it will usually form a +1 ion. So we're going to put H with the +1 up here. And so how do we go from an atom of hydrogen with 1 valence electron to a hydrogen ion with a +1 and no electrons? Well, we must have lost that electron. So that electron goes elsewhere. So this is lose. And the reason we know that we have lost an electron is because electrons are negative. So let's look at the hydrogen atom. So hydrogen atom, right now we have 1 proton and 1 electron, right? 1 positive, 1 minus, and so we have 0 charge on that hydrogen atom. But we have 1 valence electron, which is why we have the 1 dot. And then the hydrogen ion, H plus 1 ion, we still have 1 proton because it's hydrogen, but now we have 0 electrons. So we had 1 electron, now we have none. So we lost 1. Okay, number 3. How many valence electrons does hydrogen have after it loses its 1 and only valence electron? 0. It had 1, now it has 0. It lost its 1 and only electron. Now it's down to 0. Now calcium. How many valence electrons does calcium have? We said it was in group 2, so it has 2 valence electrons. This is what the calcium Lewis dot diagram would look like. We'd put Ca for the symbol for calcium. There's our beautiful dot, and there's our second beautiful dot. 2 dots. Where you put them really doesn't matter. And that dot kind of looks like a cloud. This one does too. Anyway, so when it becomes an ion, it's going to lose both of them. Whoop, whoop, they're both going to leave. And the number of electrons that leave is equal to the charge. So this will be a +2 charge. So the answer to this one is +2. All right. Great, great. Easy peasy. Okay, so today's assignment, and I'm actually going to edit this a little bit. Ionic bonding classwork. All right, so 3 assignments today. They're not all due today. One of them I'm going to give you some time on, but we have to practice doing this stuff. So day 11 is our warm-up. We just did that. And then we're going to do this Nearpod, which is not pretty short, not too bad. And then we've got ionic bonding classwork. Okay, so since we're drawing stuff, I'm doing Nearpods instead of Edpuzzles. So today we're going to review how to determine the number of valence electrons in an atom, and then how to draw a Lewis dot diagram for ionic compounds. Okay. Learning objectives. Students will be able to determine how many valence electrons are in an atom or ion based on its location on the periodic table. We're going to review that. We've been talking about that. We're going to review that. And then students will be able to draw the Lewis dot diagram for ionic compounds. And these aren't too bad. A lot of the same stuff that we've been talking about is going to be used, and then we're just going to draw a picture of it. Okay, so electrons are these negatively charged particles that orbit the atom. The valence electron shell is the outermost shell. And the group number of where the element is on the periodic table will tell you the number of valence electrons. Okay. So here's our, basically this is a list of which group it's in and how many valence electron it has. So we've got group 1, 1 valence electron, group 2, 2, group 13 or group 3, 3, group 14 or group 4, 4, and so on, all the way up to 8. And then once we get to 8, we're full. Okay, here is our, basically the periodic table with our valence electrons labeled. So if we are in the far left corner, we have 1 valence electron, which means a +1 charge. And then if we're in group 2, we have 2 valence electrons or a +2 charge. If we're in group 3 over here, or if you see 13 on the periodic table, or 3A, I think is what it says, 3A, that'll be +3. This will be plus or -4, which will be 4 valence electrons. This will be 5 valence electrons, which will be a -3. This will be 6 valence electrons, or a -2. This will be 7 valence electrons, -1, and then 0. And we'll talk about how we get these numbers here a little bit today. So you can look on the periodic table, see where the element is at, and get the number of valence electrons. We're not going to worry about this section here, okay? These do not follow the rules, so we're not going to worry about them. All right, so how many valence electrons are in each of the following neutral atoms? Okay, well, if we look on our periodic table, let's see if I can minimize this to something. Oh, there's my little man. So let's put this here. And let's see. Okay, there we go. And then let's get our periodic table. Aha. Okay. So let's erase, and let's just circle these elements on the periodic table and identify how many valence electrons they're going to have. All right, so lithium is right here. So he's going to have 1. And I can't draw on this unless I'm presenting. So we're just going to look at our periodic table here, okay? And then we'll go back and flip over. So we're doing lithium. And then what's next? Let's see if I can move this. Oh, come on. There we go. And then, aha. Okay, so lithium is right there. So that's 1 valence electron. Barium is down here. So that's 2. And then aluminum is right here. So that's 3. Phosphorus is right here. So that's 5. Chlorine is right here. So that would be 7. Argon is right here. So that would be 8. Helium would be 2. Now, helium is in group 8, but he only has 2 valence electrons. That's very important to remember. Helium is equal to 2. He's only got 2 protons, and he only can access that first shell. And remember, the first shell can only hold 2, so that's his max. He can hold 2, and if we ask ourselves, how many valence electrons does helium have? It's 2. Even though he's in group 8, it's still 2. All right, so a lot of times students will miss that. Nitrogen is 5. Okay, so let's open our PowerPoint or a Nearpod. We're going to draw on it. We're going to draw, 1, 2, 3, 5, 7, 8. Now, argon's a noble gas, and he's in group 8, so he's 8, but helium is 2, and then nitrogen is 5. And so if I drew the Lewis dot diagram for each of these, which you guys don't have to, but if you want to, you can. So there's lithium, barium, aluminum. So I'm just showing the picture that has the symbol with the element and the number of dots. That's all a Lewis dot diagram is. Phosphorus is 5. And where you put the dots really doesn't matter. I'm just putting them where I know they go. But as long as it's got 5 dots, who cares? Chlorine would have 7 dots. Argon will have 8 dots. And this is what an atom looks like when it has a full outer shell. It's going to have 4 pairs of electrons completely surrounding the atom. So that's a full outer shell. Helium will have 2. And I'll put them on opposite sides just because it looks nice. And then nitrogen will be 5, just like phosphorus. 1, 2, 3, 4, 5. Okay, so there's our number of valence electrons, and there's our Lewis dot diagrams for neutral atoms. Easy peasy. Now, positive ions. These are ions with a charge. When a metal becomes positive, they're going to lose electrons. So, for example, potassium is in group 1, and he has 1 valence electron. So this actually is going to be our Lewis dot diagram for potassium. It's going to be K and then 1 dot. All right, so potassium is going to lose an electron. Okay, why is potassium going to lose an electron? Well, let's see how many. What's his atomic number? 19. Oof. Okay. So if we put K, here's his nucleus. We're going to put 2 electrons there. We're going to put 8 electrons there. I think we're going to put 8 electrons there. That's 16, 17, 18. Okay, and then we got 1 electron left. All right, so check this out. So this is potassium. This is a neutral potassium ion. We write K in the symbol. Now remember, we're only worried about the outermost electron shell. So we're only worried about this 1 electron right here. I wanted to make that a different color. I'm not sure why I didn't do it. There you go. So here's our 1 electron. That way you can see it a little better. So there's our 1 electron, which is this one. And that's the only one we're going to show in the picture because that's the only one that matters. The rest of these electrons are inside the atom and they don't really do anything. So this guy is going to leave. Shoop. When he does, he's going to become a +1 with no dots. So he's naked, okay? And that's what it looks like. So it's going to be positive and no dots. So he's naked. And this is what's going to happen every time a metal becomes an ion. Now, why does potassium do this? He's got 1 electron in his outermost shell. Everybody see it right there? That electron's just chilling. And it doesn't like that. It wants to have a full outer shell. So what he can do is he actually can lose that 1 electron. So there goes that electron. And notice what happens to the shell. The whole shell disappears. Now let's evaluate what's left. Now we have a +1 charge because we lost an electron, and electrons are negative. So now we have 19 protons and only 18 electrons. 19 plus minus the 18 gives us a +1. So now we have 1 extra proton. So now we have a +1 because we lost a negatively charged particle. And we have a full outer shell. I mean, look, here's the inner shell, that's 2. Here's the second shell, that's 8. But look at this third shell, it's 8. So this is how metals will fulfill the octet rule. This is how they will get to 8. They're very happy when they get 8, and that's how they do it. They're going to lose that outer shell. If that outer shell has 2 electrons in it, for like calcium, they're going to lose both. Potassium, in this case, just loses the 1 to become a full outer shell. Aluminum will actually have 3 electrons in that outermost shell, and it's going to lose all 3. And again, the charge is equal to the number of electrons that leave. Okay, how many it loses. So that's what metals do. Very cool. Negative ions, atoms with a charge. So when nonmetals become charged, they gain electrons instead. So let's look at chlorine for an example. Chlorine is in group 7. So he will have 7 dots. Notice 7 dots over here. So this is the Lewis dot diagram for the chlorine atom. All right, and so what is he going to do? He's got 7 electrons in his outermost shell. He is going to pull an electron to himself. He's going to violently take it from pretty much anything he can. This is what we call electronegativity. It's where an atom behaves like a bully. It is going to pull electrons from other atoms. Whether they like it or not, it's going to take it. Okay, so it's going to take an electron. It's going to bully that poor atom, and it's going to gain an electron. So chlorine is element, I forget this, element 17, okay? So chlorine will have 17 protons The atom of chlorine will have 17 protons, 17 electrons. But then we gain one, and so now we have 18 electrons. So what is an 18 minus plus a 17? What's the net there? What's the net change? Net when we subtract these, we get a -1. So that's why it's net -1, and we get that extra dot. So now we have 8 dots. So this is what nonmetals will do. However many electrons they have in their valence shell, they're going to fill it. So chlorine, for example, just like fluorine, bromine, iodine, all of these guys are -1 when they become ions, and that's because they're in group 7. They have 7 valence electrons. They need 1. They're going to grab that 1 electron, and what do you know? They become -1 charge, and they have full outer shells. So fluorine will look like this. 8 dots completely surrounding the ion and a -1 charge. So that's what they're going to do every single time, every nonmetal. Now, it may gain 2 electrons, like sulfur. Sulfur has 6 valence electrons, and it looks like that. 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6. So this is the Lewis dot diagram for sulfur. It's in group 6, and so it's going to pull 2 electrons from something. It's going to pull them violently. Again, this is called electronegativity. It's going to have 2 more electrons there, and it's going to be a -2. Again, the charge is equal to the electrons that are added. Oh, that looks like a face. Okay, so that's the electron dot diagram for sulfur. So this is what nonmetals will do. They will have a full outer shell, 8 electrons around them, so 4 pairs of electrons, and then some kind of negative charge, and that charge is equal to how many electrons that atom had to grab in order to reach 8. Fluorine had 7, it needs 8, so it's a -1. Sulfur has 6, it needs 8, so it grabs 2, so -2 charge. Oxygen will do the same thing as sulfur here. So you can replace that with an O, and that will be the Lewis dot diagram for oxygen. Same thing. Okay. So let's practice. How many valence electrons are in each of the following? So calcium with the +2. Calcium is in group 2. And I don't have to write this yet. So group 2. And so it's going to lose those 2 electrons. So the original Lewis dot diagram for calcium would be this. And it's going to lose both of them. Boop, boop. They're both going to leave. And so we're left with a Ca +2. So how many valence electrons does it have now? Technically 0. It has completely erased that 3rd or 4th shell. And so now it's got 0 valence electrons. So the answer for this is 0. Lithium is in group 1. It's going to have 1 electron originally. It's going to lose it, and it's going to become a +1. Same thing, 0. Now sulfur. Sulfur will have 6 electrons because it's in group 6, just like oxygen. So here's a happy sulfur chilling. He's going to grab 2 ions and become a -2. So how many valence electrons does it have when it forms that ion? How many dots? 8. Right? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then fluorine, since it's a nonmetal, will also have 8. So essentially this, for metals, they're going to be positively charged, and they're going to have 0 valence electrons when they're done. Nonmetals, which when they're like this and they look like this, I call them naked. No dots. Naked ions, okay? And then nonmetals are going to be negatively charged, and they're going to have 8 electrons. Now, the exception to this is hydrogen. Hydrogen, his max is 2. Hydrogen cannot have 8. So hydrogen's plan is to get to 2 electrons. All the other elements, all the other nonmetals are trying to get to 8. Octet rule of 8. This governs everything that we see in chemistry, or a lot of things that we see in chemistry. Tells us that electrons are going to react in order to fill their outer shell and have 8 electrons in their outer shell. We've talked a lot about that, right? Okay, so let's practice drawing the Lewis dot diagram for each of these. Calcium will be Ca with the +2. Lithium will be Li with the +1. Sulfur will be 6 dots. That's 4, 5, 6, and a -2. And then fluorine will be 8 dots. Oh, no, it's going to be 8 dots. Why did I say 6? It's got to have a full outer shell, right? So 8 electrons. And again, fluorine is in group 7, so it needs 1 to get to 8, so it's going to be a -1 charge. Sulfur is in group 6, so it needs 2. So it's going to be a -2 charge. So there are the Lewis dot diagrams for those. So draw those on your Nearpod, please. Easy peasy. All right, now some just general notes about Lewis dot diagrams. A Lewis dot structure is a two-dimensional, quick and easy diagram that shows the element's valence electrons. It only shows valence electrons. The nucleus of the element is represented by the symbol on the periodic table, and the valence electrons are represented by dots around the symbol in pairs. What are the rules for dot structures? No side can have more than 2 electrons or more than 2 dots. And you're supposed to try to put electrons in the 4 corners. So if you imagine north, south, east, west, you're supposed to only put 1 dot on each corner before you start pairing them up. And the reason for that is because these electrons repel each other, and so they don't want to be paired up until they have to. Okay, so you can think of them as like siblings that fight. They're not going to want to share a room until you force them to, right? They're going to want to have their own space, and so you have to have 1 electron in each of the 4 directions before you start pairing them up. And then once you start pairing them up, it's like then they'll deal with it. It's fine. But until then, they're going to try to have their own side. Now, the exceptions are hydrogen and helium. Hydrogen will look like this. Or if you have the H -1 ion, it'll have 2. And then helium will look like this. Now, where you put the dots really doesn't matter as long as it has the correct number of dots and the correct symbol for the element. That's all that really matters. Okay, Lewis structures. So how do we write the Lewis dot diagram for an ionic compound? We're going to find the 2 elements on the periodic table. We're going to determine the number of valence electrons. This is how many dots you'll draw. Metals will be naked with no electrons, and they'll be positively charged. Non-metals will have full outer shells, 2 for hydrogen and 8 for all other elements, and they will be negatively charged. Okay, so here's an example. Sodium is in group 1, so sodium has 1 valence electron. So he will lose it and become +1. Chlorine is in group 7, so he will have 7 valence electrons. He's going to gain 1 electron to get his 8 electrons, to get his octet, and a -1 charge. And so when we draw the Lewis dot diagram for sodium chloride, NaCl, we're going to show these just together. So I'm going to do that. Notice that we got the symbol for the metal. We have no dots, so they're naked. And then we have chlorine right next to it. So just put it next to it. And then he's going to have all the electrons. He's hogging all the electrons. That's what nonmetals do, especially chlorine. Chlorine's extremely electronegative. And then a -1. And so if I put a box around that, there is our Lewis dot diagram for sodium chloride. So what can vary when you do these Lewis dot diagrams? The symbols for the elements will vary, the charges will vary, and even the number of each atom will vary. Notice that the formula for sodium chloride is NaCl, and so when we write the Lewis dot diagram, we indicate 1 sodium atom and 1 chlorine atom. If I had aluminum oxide, Al2O3, and I drew the Lewis dot diagram for that, I would need to have 2 aluminum atoms drawn, each with its charge, and then 3 oxygen atoms, each with their charge, like that. And so this would be the Lewis dot diagram for aluminum oxide. Now the only thing difference is we would need 8 dots around all of these guys. And this kind of gets tedious, but especially if you're doing it on paper. Well, actually, either way, I mean, it's probably worse because then you're you're doing a lot of poking when you're writing this. You're making a lot of dots and it gets kind of annoying. So there's our Lewis dot diagrams. So here's some definitions and some things about ionic. Ionic compounds are formed between a metal and a nonmetal. They're going to form when electrons are transferred or exchanged between atoms. Sodium chloride is an example. We talked about properties of ionic compounds. They make crystals. They have high melting and high boiling points. They are electrolytes, which means they conduct electricity when they're in solution. They will form a solution, so they will dissolve and mix with water when you put them, so they are soluble. They will mix with water, which is what that means. We talked about the naming rules. The first element name is the same, and we change the second name to IDE. And all these ions that we're seeing, let's say like here, we're talking about potassium or fluorine. So if I talk about just this ion right here, like this right here, let me circle it. So if I talk about that right there, I'm going to call that the fluoride ion. So remember, we changed the name to IDE if we're talking about a negative ion, okay? All right, so let's go through here. Okay. Well, I got to go back. Okay, so here's our example. Potassium fluoride. So KF is the symbol, the formula, potassium fluoride. The metal is going to be potassium. And here's the Lewis dot diagram for our metal. His electron will be green. And then we have fluorine with his 7 electrons because he's in group 7. He's in group 1, so he's got 1. And what's going to happen? These two are going to find each other. Potassium's like, I got this 1 electron. I don't want it. I'd be so much happier if someone would just get rid of it. And then fluorine's like, really now? I'll take it. I have 7. I need 8. I'll take it. So there we go. Oh, and why is this not playing? It's supposed to do like a little animation, but it's not doing it. I don't know why it's doing it, but it's supposed to go. It's supposed to go over there, but it's not doing it. I don't know why. That's annoying. Okay. And then calcium oxide, CaO. Calcium's got 2 valence electrons because it's in group 2. Oxygen has 6 valence electrons because he's in group 6. And so the 2 calcium electrons will be taken by the oxygen. Calcium will become a +2 because he loses 2 electrons. And then oxygen will be a -2. And he will have, oh, where's oxygen? Let me draw on the oxygen. I didn't have any problems with this PowerPoint like an hour ago at school. I had no problems with it. There we go. So it'll have 8 dots around it and a -2. And then potassium oxide will have the K, we'll have the O. Notice that oxygen needs 2 electrons, right? There's a hole here. There's 2 electrons missing. And so one of them will come from this potassium, but the potassium will have to find a buddy to come and join the party. So 2 potassiums will be needed to fill the octet for oxygen. Oxygen needs 8. He's got 6, right? So he's going to need 1 from each of these potassiums, and that'll give him 8. There's oxygen with -2. He gained 2 electrons, so -2. All right, lithium bromide. We're going to have 1 lithium with a dot. We're going to have bromine with 7. Lithium's going to lose that 1 electron. Bromine's going to take it, and we're going to form our ions and our charges. And you can tell the color here. You can tell which electrons are donated by the metal. Calcium chloride. Calcium has 2 valence electrons. It's in group 2. Chlorine has, or I should say chloride, has 7 valence electrons. And so it has space for 1. So one of the electrons here will go to 1 chlorine, but then it's going to need a twin. And then that twin will take the other electron. And then we can draw our Lewis dot diagram. And you can see the 1 electron donated from calcium. Sodium nitride, kind of the same thing. Sodium has 1 valence electron. I don't know what happened here. This is weird. Nitrogen has 5 valence electrons, so he needs 3. And so he will take one from this sodium. So he's going to take it, whoop, and then he's going to have 2 others come in, and he's going to take both their electrons too. So he's going to have 8. And so that will be the Lewis dot diagram for nitrogen. Okay. So here's a bunch of examples. Okay. Now let's talk about the classwork. I'm going to do half of it. And if you guys have time to do the classwork today, that would be awesome. But if you don't, complete it on your own time. But try to do it sometime this week. Let me find the classwork. I got Cami uploads. I think I need to open Cami to do it. So let me do that. Give me a second, guys. Okay, hopefully this works. So this is a Cami. It's basically a document where it'll allow you to edit it. And so you guys will need to do this for the classwork. So you'll go to the classwork here. Let's see, modules, unit 2, so ionic bonding classwork. So you'll open that. I'll give you guys a link for that. You'll have to just click on the link here, and it'll open this up. So you have this document, and you might be able to edit this in Canvas. I'm gonna try to set it up so that you can draw on it and do everything you need to do within Canvas without having to go to a second website and log in. So I should be able to set it up so that you shouldn't have to. You should be able to work on the document within Canvas and not have to go to a second website. So you should be able to do it within Canvas. So what you do once you open it is you go over here and there's your drawing. You can pick whatever color you want. I'm gonna do black so that y'all can see it, but whatever color you want to do. Try not to do yellow. I won't be able to see what you're doing, but the other colors are fine. Put your name up here, and you can kind of just write on it like a paper. So potassium fluoride is KF. I think first what I'm gonna do, guys, is I'm gonna go down the list and write the formula for these. So I'm gonna do that one. I'm gonna skip that one. I'll do this one. BES. Let's do this one. This one's a little tricky. ALBR3. This one's interesting. Li3P. What that is. Where's my eraser? There you go. Let's try that again. Li3P. So I'm determining the formulas for the ones I'm going to do with you guys. Let's do this one. This is CaSe. I'm pretty sure. Selenium is in group 6. Yep. Okay. What else? I'll do this one. Magnesium bromide is MgBr2. This is Ca3P2. Yep, Ca3P2. That one's a little tricky, so we'll do that one together. Al2S3. And then this is K3P. Okay, so we got the formulas for these guys. And so what I'm going to do is I'm going to take the formula and write each of the symbols for the elements, okay? So this is K. Potassium is in group 1, so I know it's going to be a +1. And then fluorine is in group 7, so it's going to be a -1. And then I'm going to put 8 dots around fluorine. And so there's our Lewis dot diagram. Ain't that nice? Here's beryllium sulfide. Beryllium is in group 2, So it's going to lose those 2 electrons to become a +2. And then sulfur will have 8 dots. And this time it'll be a -2 because it has 6 valence electrons and it needs to get to 8. So it's going to have a -2 charge to get to 8. So notice that the nonmetals are full and they have a minus charge. The charges vary. But then you have a naked metal with a positive charge. All right, aluminum bromide. AlBr3 is what that says. AlBr3. All right, so aluminum is in group 3. So he's going to have 3 valence electrons that he's going to lose to make it +3. And then we're going to need 3 bromine ions here. And actually, let me erase the formula here. So AlBr3 is the formula. Let me write it over here. AlBr3. All right, so we're going to need 3 bromines. So let's kind of space them out. All right, they're each going to be a -1 because bromine is in group 7. So it's going to have 7, which means it's going to need to get to 1. And I'm going to put 8 dots around every one of these. This kind of gets tedious. So 8 dots around each of these bromine ions. And so that's our Lewis dot diagram there. Lithium phosphide is going to be 3 lithiums, each with a +1. You can put plus or +1. And then we're going to have phosphorus, which will have 8 dots around him. Phosphorus is in group 5. And so if he's got 5, he needs to get to 8. So he's going to have to make a -3 to balance with a +3. So that's the formula. That's the Lewis dot diagram for lithium phosphide. Calcium selenide will be Ca with a +2 because calcium's in group 2. Selenium is underneath oxygen. So we're going to need 6 electrons there and then 2 more to get to 8. So that's a -2. So that's kind of the way that you do these nonmetals is you draw the number of electrons that it has based on where it's at on the periodic table. So selenium had 6. And then from there, add electrons until you get to 8. And the number of electrons that you add is equal to the charge. So it's really that simple. I know it seems confusing, but it's really that simple. Okay, magnesium bromide. Magnesium, if we draw the Lewis dot diagram for magnesium, he's got 2 dots. He's going to lose them both, so I know it's going to be a +2. And then, +2. Bromine is in group 7. So if I draw the Lewis dot diagram for bromine, he's got 7 dots, and he needs to gain 1. So he's got 7 of his own. He gains 1. And so that means he's going to be a -1. And we're going to need 2 of them. So we're going to do 2 bromines, each of them -1, and then 8 dots. There we go. Calcium phosphide, we're going to have 3 calciums, each with a 2+. And if you want to put +2, that's fine too. It's the same. It doesn't matter to me. And then 2 phosphorus ions, each with 8 dots around them. And they're both going to be a -3. Okay, the reason I know that it's a -3 is because phosphorus is in group 5, and we got to get to 8, which means that we need 3 electrons to make that happen, so they're each going to be -3. And you guys know how I got the formulas, right? Calcium is a +2. Phosphorus is a -3 because of where they're at in the periodic table. They change places. So the 3 from the phosphorus goes down, and that's why I have 3 calcium ions. The +2 right there on calcium tells me that I have 2 phosphorus ions. So we're balancing the charge to get those formulas. All right, aluminum sulfide. Aluminum is a +3. We need 2 of them. And you guys might have some trouble here with the room being able to write all this in this little space. So you might want to zoom in kind of like I did so that you can write everything. And you might want to write small. And this is kind of fun. I like drawing loose diagrams. I think it's fun. Potassium, we got +1. We're going to have 3 of them. And then we're going to have 1 phosphorus with 8 dots. and a -3. And then we'll do potassium oxide for fun. This is K2O. So 2 potassiums, an oxygen with a -2. Okay, now I want you guys to do the rest of these. I'll give you the formulas, okay? You should be able to determine the formula on your own, but I will give you the formula. Magnesium iodide is MgI2. And again, this is not the answer. I want y'all to draw the Lewis dot diagram. Okay? Sodium oxide is Na2O. So draw the Lewis dot diagram. Don't just copy what I have. I can't give you credit for that. I need you to complete these. Okay? I'm not asking for a whole lot here. We're only doing 1, 2, 3, 4, 5, 6, 7, 8, 9 problems. Maybe I'll do some more here. Y'all can copy them. So strontium sulfide will be Sr2 plus and then S minus 2. There you go. I'll do that one for you. We'll do this one. Barium selenide will be Ba plus 2, S minus 2. Okay. So that's 1, 2. I'll try to get it down to y'all just have to do 5 of them. How's that sound? I do want you guys to complete the worksheet. So when you turn it in, every one of these boxes should have a Lewis dot diagram in it. But I'll leave a couple for you guys to do. So that one's good. So at this point, we got 1, 2, 3, 4, 5. I got to do one more. Barium sulfide. There we go. That one's done. So I'm going to leave these 5 for you guys, okay? So number 3, there's the formula. Again, draw the Lewis dot diagram. Sodium oxide, here's the formula. Potassium iodide is Ki. That's the formula. Draw the Lewis dot diagram. Lithium chloride is LiCl. Draw the Lewis dot diagram. I'll give you guys all the easy ones. This is Ali3. Draw the Lewis dot diagram. So I just want y'all to do those 5. 1, 2, 3, 4, 5 that I circled. So number 3, 7, 13, 12, 14. Do those on your own. I wrote the formula. Write the Lewis dot diagram like these. Make sure it's charge balanced. Make sure your metals are negatively charged and have the correct charge. Or I'm sorry, positively charged and have the correct charge. Make sure your non-metals are negative and they have a full outer shell. So they should have 8 dots on them. All right. And I think that's it, guys. Thank you so much. I hope you guys have enjoyed this lesson. We'll see you next time.